Time dilation is all about how time behaves depending on how fast people are moving or how close they are to something with strong gravity. Let's say we have you and your friend, and you want to go to space and travel near the speed of light on a spaceship. Now your friend's going to stay behind and he's going to observe you through a telescope. Now you both have clocks, and before you leave, you synchronize both your clocks so they're running at the same time. They're in sync. Now once you take off and you near the speed of light, your time will begin to slow down, while your friend's time back on Earth will run at normal speed. Let's say on the ship, only a few seconds or a few minutes have elapsed. Well, your friend back home might have been watching you for 48 hours. And because you're traveling so fast, time for you, because you're moving at a specific speed, is slowing down based on that speed. So the faster you move, the slower time gets. Now, this brings us to another point, which is absolute rest. And this is a very important idea. Absolute rest is the idea that you're never moving, that sometimes you're still. Let's say you're at the beach and you take your chair and you sit down, you're at rest, but you're still moving because the planet is moving, it's rotating, and it's orbiting the sun. And so in that sense, you're not really still, you're still moving through space. And because you're moving, one could say that the vehicles that are passing by you at the beach, they might be at rest relative to you. And you're the one passing them by because they're moving along the globe while the globe's rotating. So they may be at rest relative to you, and you may be at rest relative to them. Most people don't really think about it unless you're going through a STEM major, physics or engineering, because once we can really wrap our heads around the fact that absolute rest, being still in motion, does not really exist, then that really makes it a lot easier to digest the idea of time dilation. Because we're all moving, everything in the universe is expanding one way or the other. And so with that motion, with that expansion, time in different areas is moving a lot different. This brings us to another point that I think pairs nicely with time dilation, and that's look-back time. Let's say there's a planet a million light years away, and we could see that through our telescope here on Earth. It's taken a million years for that light, that image, to travel through space into our telescope so that we can view it. Within those million years, a lot of things have happened. That planet might have exploded somehow, and there's no way to know that unless we literally wait those millions of years to see what actually happened. And so we will never be able to catch up to any object at those distances in real time. We'll always be behind. That's look back time, because light travels at a specific constant speed, 300,000 kilometers per second, and that never changes. Light cannot travel faster than that, and so we're at the mercy of that speed. We're at the mercy of that constant in how we observe the universe around us, the positions of stars, of galaxies, of black holes, how far they are from us. We're at the mercy of light speed. It's pretty amazing. And so that really puts a lot of things in perspective in terms of space travel, research. What could humans realistically accomplish in research when it comes to astrophysics? But it's not a closed door. It's just that we need to think more creatively and tune our expectations to what we can actually accomplish within laws of physics. If we had a telescope that was able to look at that planet that's a million light years away, breach its atmosphere, and look into its cities, we would be watching cities that existed millions of years ago. If there's vehicles in that city, people walking around, it's a window into the past. Even though we cannot physically travel to the past, we can theoretically view it in our own real time. Now, if you enjoy this video and you want to learn more about physics, hit the subscribe button and the notification bell so that you'll be notified every time we have a new video. We'll see you on the next one.